This video draws into focus a unique historic event in astrophysics that intersects with the greatest science challenge before us, on which the future existence of humanity largely depends. The science challenge in this case is the great challenge to humanity and its science to respond to the ongoing electrodynamic weakening in the solar system that promises an inactive sun in the 2050s time frame, with immense consequences for humanity. The consequences can be avoided when the challenge is understood, acknowledged, and is responded to. This video presents a unique item of evidence in that context. The evidence is valuable to the whole. The video also intersects with the video "The Greatest Science Challenge in the History of Civilization" and the video "New Ice Age Near, 58-Part Evidence." The following presentation intersects with these videos because the rather amazing astrophysical event that this video is focused on hadn't occurred when these earlier videos were produced. But before the new event can be drawn into focus, it becomes necessary to set up a wide stage for it, and in some respects also a rather basic stage. For example, it is reasonable to forecast that in 10 hours this bright noonday landscape will be dark. Of course, it is reasonable to forecast this change based on historic precedents. But it is more reasonable to forecast this change based on our understanding of the principles of the solar dynamics. Likewise, it is reasonable to forecast that in half a year's time the brilliant berries will be wilted and withered away. We can make this forecast again based on historic precedents, and again too by acknowledging the dynamically self-renewing and self-expanding cycles of life. In forecasting the future, especially in cases that are less simple than the two examples presented here, it becomes important to understand the principles involved and their dynamic unfolding. On this basis, it is not unreasonable to forecast with relative certainty that the sun may go inactive in the 2050s time frame, based on evidence in hand that enables us to understand the principles of solar dynamics that cover a wide horizon of time, but which are inherently knowable and can be responded to, and if so, open a whole new horizon in the adventure of human living on a scale that we can barely imagine yet. Here the greatest science challenge begins. For tackling the science challenge, let's widen the visual perspective of what the diminishing numbers of solar wind pressure represent, which is critical for a reasonable forecast. For this, let's step back a bit and take a sweeping look at the gigantic landscape in which the solar dynamics unfold. The gigantic landscape is a landscape of plasma. Researchers at the Los Alamos National Laboratory, together with other researchers in plasma physics, have come to the recognition that 99.999% of the mass of the universe exists in plasma form. The term plasma refers to the blood of the universe. Plasma pervades all space in gigantic streams. It powers everything, every galaxy, every star. Plasma is made up of electrically charged particles, named protons and electrons. Plasma is invisible because its protons are 100,000 times smaller in size than the smallest atom, and its electrons are 1,000 times smaller than that. The protons themselves are made up of 3 smaller constituents, called quarks, which are theorized to be but moving points of energy. By this definition, no matter actually exists in the universe. The physics researcher David Bohm recognized long ago that so-called empty space is in reality a sea of latent energy, with ripples forming from which everything is created by a vast array of universal interacting principles. By this definition, plasma and space are one. Plasma is formed by the nature of its dynamics, and its organization in space is shaped by the electromagnetic force of the universe. Moving electric currents create magnetic fields, which act on the currents to draw the sea of plasma into large organized streams. The same form also pinches the streams ever tighter, until the concentration becomes so great that explosive node points result, where plasma dissipates. At this point, plasma expands again and moves on, collecting more plasma as it flows. Our Sun is located at the center of one of the node points. Instead of plasma exploding at the node points of our Sun, the Sun consumes the plasma. Plasma is consumed by the Sun in a process that enables such dense concentrations of it that the plasma particles fuse together into atomic structures that are electrically neutral, which subsequently flow away with the solar wind. From this wind of synthesized atoms, the planets are formed. The theory is correct that the planets are formed from the coalition of cosmic dust, though it is rarely acknowledged that the cosmic dust around the Sun is created by the Sun itself. The magnetic environment at the node points is complex, but it is knowable. It has been replicated in high-powered experiments at the Los Alamos National Laboratory, and it has also been explored in static experiments by the researcher David Lapointe, who has termed the electrically created magnetic fields at the node points the primer fields. He has demonstrated in experiments that plasma is concentrated into a tight sphere between 2 complementary magnetic fields, which together form a large magnetic field around them. Recently discovered evidence shows that this type of process happens on the galactic level too, where the resulting geometry in plasma matches in principle the experiment-derived geometry. The dome-like structures shown here are magnetically created at the node points of large intergalactic plasma streams. The plasma concentration is so great there that stars are formed as concentrated plasma spheres, which the galaxies are largely made of. The centrally formed stars are themselves powered by vast flowing plasma streams that pervade the galaxies in large, electrically organized, rotating plasma streams that we see in the form of such features as spiral arms, and so on. On the small scale of our tiny solar system that operates within the spiral plasma streams, the node point is just as complex as that for the galaxy, only much smaller in scale. In cosmic space, galaxies typically appear in short or long string-like arrangements according to their node points, as do stars appear arranged into strings like beads on a necklace, as in this Hubble image. Our star, the Sun, is no exception. The Sun is located at a node point of a substantial interstellar plasma stream. Its primal fields concentrate the plasma stream into ever tighter confinement. If we narrow our wide view into what specifically exists at the node points of our solar system, then the largest astrophysical structure that we encounter as a part of the node point that is centered on our Sun is the Oort cloud. Note, the drawing is not made to scale, but merely illustrates a principle. The Oort cloud, according to recent discoveries, is a hollow, spherical shell made up of trillions of asteroid-like objects, larger than a kilometer wide, and many billions of them being 20 kilometers in size. It is believed the Oort cloud extends from up to 50,000 astronomical units from the Sun, which is the measure of the distance of the Earth from the Sun, to up to 200,000 astronomical units, or AU. That's huge. The cloud's objects are kept in place electromagnetically. No other known force could have this organizing effect. The Sun's gravity and magnetic field do not reach to such great distances. The entire Oort cloud can therefore be seen as the focal object of a set of large internal primal fields. Inside the giant sphere, a much smaller donut-shaped inner cloud is nested, which covers the space between 20,000 AU and 50,000 AU. It appears to be governed by its own primal fields, nested within the big sphere. At the center of the inner cloud, as shown here in blue, exists a still smaller nested dynamic structure, which may be termed the heliosphere system. It contains the heliosphere at its center, with all the planets and the solar system, including the Kuiper belt and the asteroid belt. This structure is tiny. It is a mere 100 AU wide. And again, it appears to have its own primal fields. Here again, at the very heart of the heliosphere system, we have nested within the inner sanctum still another primal fields system. This deeply nested system is the one that directly powers our Sun. It focuses high concentrated plasma around the Sun. It may therefore be termed the corona system. It is the critical heart of the solar system. This means that we are dealing with a multi-level electrodynamic system of nested primal fields, ranging in size all the way from the gigantic to the very small. Obviously, each one of the nested systems has its own electromagnetic resonance according to its size. Most are represented in the ever-changing climate record on Earth. The outer cloud, by its immense volume, appears to have a 5,000-year internal resonance. It took 5,000 years for the interglacial to be established, which is not shown here. It was followed by a 5,000-year hot cycle, and after that, by the 5,000 years cooling cycle that is still ongoing. The long 5,000-year cooling seems to indicate that the Oort cloud may now be electrically empty. This means that with an empty sphere surrounding the inner Oort cloud, it too has been fizzing out. It appears that its last 2,000-year cycle briefly recovered at the midpoint, but collapsed after that. The heliospheric system, with its roughly 250-year resonance, tried to stage a recovery, but it being surrounded by a largely empty plasma landscape, the recovery didn't materialize. The Little Ice Age resulted from that. The low portion of the 250-year resonance that gave us the Little Ice Age started slightly more than 500 years ago. Since there was apparently enough strength left in the surrounding systems at that time, the following 250-year resonance resulted in the climate recovery in the mid-1700s that gave us the much politicized global warming period, which too has now run its course. We are presently in the beginning zone of another down cycle. The recovery from this resonance should theoretically happen in the 2100s time frame. However, with the heliosphere system being surrounded by a largely empty plasma landscape, this repeat recovery appears highly unlikely. The Sun's corona system, which operates within the 250 years system, runs its own 11 years resonance. Its rather short resonance cycles are fast becoming weaker. Since this innermost system is likewise surrounded by an empty shell, it too will likely collapse long before the 2100s are reached. The collapse may happen in the 2040s. That the Sun's corona system as a whole has become rapidly weaker is not only evident by the reduced sunspot numbers, but is also more directly visible as a diminishment of the Sun itself. Technological advances have enabled us to look at the Sun more intimately than ever before. Advanced satellites enable us to look at the Sun's radiation in the high-intensity light bands that fall outside the visual spectrum. The space-based observation systems that are now in use measure the invisible light bands ranging all the way up to the X-ray bands and present the result to us in visible colors. These satellite systems enable us to observe in fine detail what is going on in the Sun's atmosphere, which is made up of atomic gases that were synthesized on the surface of the Sun. The Sun's atmosphere consists also, to a large degree, of electric plasma. By the interaction of the gases with the electric plasma, invisible light is being emitted, which the satellites can detect. when the invisible light show that surrounds the sun is made visible electronically. The added coloring reveals a solar corona that is not at all calm, but is a giant jungle of electric activities and gases heated to high temperatures, ranging from 50,000 degrees upwards, shown in red here, up to 100 million degrees, as shown in the X-ray image, enlarged. NASA's Advanced Solar Observatory, the SDO satellite, employs 4 different cameras to detect the invisible light, which is subsequently represented in 4 different colors. The 4 different colors also represent 4 different temperature ranges. The invisible light from the coldest objects is represented by SDO colored in red. It represents areas in the corona where the atomic gases are heated by interaction with plasma to 60,000 degrees. The bright spots on the red image are not hotter in temperature, but represent areas where greater plasma density exists in which more light is emitted. The light with the shorter wavelengths of 171 angstrom comes from atomic sources that are electrically more agitated in the plasma, to a state equivalent of a 1,000,000-degree temperature. The light with still shorter wavelengths of 131 angstrom, shown in blue-green here, comes from sources with an equivalent temperature of tens of millions of degrees. Actually, the SDO team publishes the invisible light spectrum of the ultraviolet range, divided into 7 different colors. Each color reveals different aspects of what is going on in the large corona surrounding the sun. This means that when several of the colors are combined, an amazing dynamic circus of electric interaction and dynamically created magnetic fields comes to light. In these images, drawn from invisible light, we can see evidence of vast movements of electromagnetic interactions between streams of plasma and atomic structures. Some of the visible evidence, of course, pertains specifically to the now ongoing electric weakening of the solar system as a whole, especially in the corona system, where the interstellar plasma interfaces with the sun. One of these specific items of evidence was photographed recently by the SOHO satellite. In this photograph, produced on the 21st of July 2014 at 0100 hours, strong incoming plasma streams from the primal fields plowed right through the sun's surrounding corona and lit up the atomic layer underneath, producing an intense shower of light in the highest UV energy band. Normally, the incoming plasma from the primal fields becomes diffused high in the corona, since the corona is a large and dense plasma sphere. However, in times when the corona is weaker, when it is less dense, the inflowing plasma becomes less diffused, so that some filaments of the inflowing plasma penetrate all the way to the surface of the sun's gaseous atmosphere. There, the incoming dense plasma heated the atoms of the gases, which the plasma encountered, to tens of millions of degrees. The incoming plasma streams from the primal fields may likewise diffuse in a similar manner as a red sprite does that occurs during the discharge events from the stratosphere feeding into the thunderclouds below. While a sprite event rarely lasts more than a second, the deep plasma penetration from the primal fields may last for hours. We see two filaments here poking through the plasma sphere of the corona. To the naked eye, the event would not have been visible. The image shown here is recorded in extreme ultraviolet light that borders on the X-ray spectrum. When the plasma is extremely dense, the rapidly flowing electrons within the plasma agitate whatever atomic structures they encounter. By the resulting agitation, the atoms emit light. The wavelengths of the light emitted corresponds to certain temperature ranges, which is reflected in the color. The intensity of the light shown here represents not increased heat, but increased light density, which reflects the density of the plasma. In the image shown here, the incoming plasma density is likely several orders of magnitude stronger than anywhere else on the Sun. The blue images from the SOHO satellite indicate light proceeding from temperatures above 10 million degrees. This vastly greater density, of course, is what one would expect to see for inflowing plasma that powers the Sun itself. It lights up the whole neighborhood. One can even see the spreading filaments below feeding down to the surface of the Sun. The green images present the patterns of light that come from cooler temperatures in the 1 million degree range. That corresponds with lesser plasma density. In this image, too, the brightness produced by the incoming plasma surpasses anything seen on the surface of the Sun. The red images, in turn, reflect temperatures in the range of 50,000 degrees, drawn from light at a long-wave UV band, closest to the visible band. In this light, the plasma inflow is less significant, as it is too intense for such low-temperature interactions. The fact that the plasma inflow shows up immensely strong in the blue images above the 10 million degree mark shows clearly that we are looking at an immensely concentrated plasma stream that is denser than any place on the face of the Sun. But what does this all mean? Does it mean that the incoming interstellar fire is getting stronger? No, it means the opposite. It means that the plasma sphere surrounding the Sun is getting thinner and weaker, so that the incoming plasma streams plow through more readily, all the way to the top of the solar atmosphere. The hyperdense plasma streams that penetrate through the plasma corona could only have come from the primal fields that concentrate plasma in space and feed it into the Sun, which of course the Sun consumes to a large measure in its atom-synthesizing nuclear fusion process that occurs on its surface. The phantom event over the Sun that the SOHO satellite reported is not unexpected. It falls in line with what NASA's Ulysses satellite saw when its solar wind measurements were interrupted as it orbited through the focused plasma streams. It would actually be surprising if no evidence would be seen of the plasma streams terminating near the Sun. We should count ourselves fortunate that this evidence was seen. We should see it as a warning to open our eyes. Theoretically, we should not see such events, though we will likely see more of them. A similar event occurred 16 years ago, with the phenomenon occurring in the same position. As BP Earthwatch on YouTube reported, this would take us back to 1998, when the big global cooling trend began. On-the-ground measurements conducted by the Solar Terrestrial Institute at Irkutsk in Russia show a sharp drop in ground-measured annual average temperatures beginning in 1998 of 2.3 degrees Celsius in just 3 years. The researchers Bashkirtsev and Mashnish from the Institute suggested in 2003 that the solar cycles would get dramatically weaker in the early 2020s. It may well be that the solar cycle will be so weak then that no sunspots would be occurring thereafter, and that the Sun itself would become weaker in its radiated output until the primal fields for the corona collapse and the Sun goes inactive. We will likely see many more of these plasma breakthrough events as the solar corona continues to weaken in the years ahead. Of course, further such images may also be removed, as the one shown here has been removed from the SOHO database. The events obviously violate the doctrine of the Big Bang Theory, in which plasma in space is deemed not to exist, much less to play a major role. Future reports from SOHO may be pre-sanitized to conform with the Big Bang doctrine. This is where a large part of the science challenge is located. Thanks to BP Earthwatch, who reported the vital SOHO images on July 21, 2014. The historic evidence has been preserved, which we may not be able to see again. The same researcher also noted another anomaly on the Sun, occurring a mere 18 hours later on the same day in which the big plasma intrusions occurred. He noted the shape of a solar prominence that wasn't a prominence. The image on the right is a NASA SDO image. It was seen by a different satellite. It is a type of image that one would expect to see resulting from a lesser incoming plasma stream. The plasma inflow path is seen above it, which becomes suddenly extremely bright when it encounters the top of the gaseous atmosphere and then diminishes as it flows towards the Sun. The researcher at BP Earthwatch points out that this image is totally different from that of any prominence erupting from the Sun, which always erupts from a bright base. Here is an enlarged image of the plasma inflow, which dissipated towards the Sun in the manner of a sprite. It appears that it doesn't even touch the Sun, much less is erupting from it. Fortunately, other evidence also exists that we can use to monitor the weakening plasma sphere around the Sun. We find this evidence in the so-called corona holes, which are getting larger. In 2007, some small corona holes made headlines. These are areas of weak plasma density or weak gas density in the atmosphere, or both. Now we see much larger corona holes, which occasionally cover huge areas of an entire hemisphere, while their occurrence raises few eyebrows now. All of these numerous forms of physical evidence stand behind the 2050s forecast for the potential beginning of the inactive sun. The two plasma intrusions verify that the sun is not an energy source itself, but is merely an energy converter. The two cases illustrate that the energy that drives the sun is derived from plasma that comes from an external source radiating onto the sun. The two cases also illustrate rather dramatically that the plasma sphere surrounding the sun is getting weaker. The two cases also illustrate that the interruption of the solar winds over the polar regions that the Ulysses spacecraft saw at 750 million kilometers distant from the sun is evidence of the same process that became briefly visible on the sun on the 21st of July 2014. These three items can be seen as evidence that the sun is externally powered, and as such is vulnerable to supply fluctuations that can cause it to become inactive, with large consequences for humanity on Earth. The event when the sun goes inactive shouldn't be seen as a point of crisis, however. Sure, 90% of humanity will most likely perish when society doesn't respond to the solar challenge with the sun going inactive, which can be scientifically forecast by the principles involved. When this potential is missed, and society lets things unfold without being committed to building the infrastructures that are needed for the new types of living in the changing world, then the greatest crisis will erupt and much of humanity will die of starvation. But why should we not respond? We have the capacity within us to relocate all the endangered agriculture in the world, which we depend on for our living, into floating modules strung across the equatorial seas, or in part into fully self-contained indoor facilities with artificial atmospheres. We have the technologies, materials, and energy resources to do all of this. So why shouldn't we use the resources we have and build the new world with them and live? We need to build 6,000 new cities for 1 million people each to enable the relocation of the endangered nations when their territory becomes uninhabitable under an inactive sun. With the reshaping of basalt in high-temperature automated industrial processes, powered with nuclear energy, we can produce complete housing modules with such ease that we will give them to one another for free as an infrastructure for our self-development. Here, the greatest adventure in the history of civilization begins. We can upgrade our world in such a rich measure that the start of the next ice age under an inactive sun won't hardly be noticed. Isn't this something worth celebrating and implementing? But will we do it? Just imagine a world without poverty, without war, domination, hunger, and slavery. A world with free housing, abundant food, energy, beauty, and an active peace. Yes, we have all of this within reach, if we care to use what we have. Indeed, we have the power to make it so. Of course, if we don't go this route, we commit our children to death. But why should we fail? We have 3 decades of time left, potentially. A decade to meet the science challenge, to the point that we commit ourselves to put the spade into the ground and start the building. And a decade, once we start, to build the large-scale automated industries with which to build the rest. And finally, a decade will likely be sufficient to build the needed 6,000 new cities and 15,000 kilometers of intercontinental floating bridges, and the millions of acres of floating agricultural modules and indoor agricultural facilities that we will need. We are about to embark on the greatest human adventure of all times, in which our children will become proud of us and of themselves as human beings. This path promises an adventure in which we become truly human, because as human beings we are discoverers at heart, and builders and creators, with no limits in sight, and a people with an inherent love for one another, with which all is possible.